Okay, 3-point charges lie along the x-axis as shown in the figure 3. A. Calculate the magnitude and direction of the total electrostatic force exerted on Q1. Okay, good. So this question again asking about total force, total electric force. So it is find the resultant force. Okay, it's about force F. Want to find the magnitude and direction. So you need to give not just the magnitude, but also you need to give the direction. If you don't give the direction, you lose marks. Okay. And then the most important thing to take note is this one. On who? On Q1. So we just put total force on Q1. So the attention is given to only Q1. So you don't need to draw the force on Q2 or Q3. Okay, no need to draw the force on Q2 and Q3. Just draw the force on Q1. Understand? Okay. Now let us move on. Okay. So first we do question A. And be careful with all these unit. You see that this is micro. All these you need to change. This is centimeter. You need to change all to SI unit, Coulomb and meter. Understand? That's another thing you need to take note. And then another thing is, okay, now let us first, we must draw the forces on Q1. Okay, on Q1. Okay, we identify what kind of forces acting on this charge. Okay, so back to the notes, we know that if same sign, positive, negative, they repel each other. But if positive, negative, opposite charge, they attract. Okay, so let's look at the important thing is we only focus on Q1. Okay, on Q1. So let us look at between 1 and 2, Q1 and Q2. They are opposite sign, right? Opposite sign, so they attract each other. Because opposite sign. This is F2 on 1. This is F1 on 2. Okay. This is F2 on 1. This is F1 on 2. Okay. And then between Q1 and Q3, they are same sign, positive. If positive, they repel each other, isn't it? They repel each other. They repel because same sign. So this one should be F3 on 1. This one is F1 on 3. Okay. Okay. So that's it. Opposite sign, positive, negative, attract. Same sign, repel. Okay. And then between 2 and 3, no need to bother because we just want to focus on Q1. So no need to bother what happened between 2 and 3. Understand? In fact, we no need to draw these two forces also. These forces on Q2 and Q3 also no need to draw. So we can rub this off. So our focus is just these two forces, F21 and F31, forces on Q1. Okay, hold on a second. Okay, so we just focus on these two because he asked for total force on Q1. So we just focus on F21 and F31. Yeah. We want to find the resultant force of these two forces. Yeah, all the forces on other charge we can ignore. Yeah, we can ignore. Okay, so before we find the resultant, we need to find out each individual forces. We need to calculate their value. Okay, so let us start it. Yeah, let us start. So we need to find what is F21 and also F31. Okay, so okay, let's start with F21. F21 is KQ1 Q2 over R12 square. Yeah, the equation same as before. Now K we already know is a constant value. We can find from list of constant. The value is 9 exponent 9. 9 exponent 9. Yeah, 9 exponent 9. Yeah. 9 exponent 9. And then Q1 is a positive charge. Micro, so we need to change to SI unit. We need to change. Micro is exponent negative 6. Exponent negative 6. Now Coulomb. Okay. And then Q2, negative charge. So this one we just want to find the magnitude. So this charge we ignore the negative sign. Okay. So this is a vector. Remember I said before. Yeah. I said before here. Okay. When we want to find the magnitude for the vector, we ignore the sign for charge. But when we're talking about magnitude for scalar quantity like potential energy, the charge, you must have the negative sign. That one is different. Yeah, that one is different. The negative sign for magnitude, for scalar quantity, has a different meaning. It's not about direction. Okay, it's not about direction, but it has different meaning. So right now for vector quantity like force and electric field, the charge here, you can ignore the negative sign. Okay, ignore the negative sign. Yeah, for vector, ignore the charge, ignore the negative sign. Okay, on Q2. Yeah, ignore the negative sign on Q2. So we just put positive value. Yeah, so it's positive 20 micro. Micro is negative 6. Okay. Right. Now the distance between Q1 and Q2 is 12 centimeter. Oh, so again this one need to change to SI unit. So centi is exponent negative 2. Exponent negative 2. So change already to meter. Don't forget to square. Some of you forget to square the distance between them. Okay, now we calculate the value. Okay, let's calculate the value. 9 exponent 9 multiply 12 exponent negative 6 multiply 20 exponent negative 6, and then divided by this 12 centimeter exponent negative 2 square. Okay, so I got the forces is 150 Newton. Okay. So what's the direction of this F21? It is to the right. Yeah, to the right. Okay, write the direction there, to the right. Okay. Now, how about F31? F31, okay, the blue one. Okay, maybe we use the blue color right this time. Okay. So it is Q3, Q1. Yeah, between charge 3 and charge 1. Distance between 3 and 1. Okay, so let's write in the value. Okay, 9 exponent 9. Charge 3 is okay, again remember this is a modulus, so it's a vector quantity. We just want to find the magnitude, so ignore the negative sign if you have any negative sign. No, Q1 and Q3 both positive charge. So still positive lah. Okay. Q3 is 36 micro. Again, you have to change to SI unit. Micro is exponent negative 6. Okay. Exponent negative 6. Okay. And then the Q1 is 12 micro. Okay. Also change to SI unit. And then divided by distance between Q1 and Q3. So how far is it? It is 12 cm plus 20 cm. It is 32 centimeter. 32 centimeter. 32 centimeter. So centi is exponent negative 2. Exponent negative 2. Okay, meter. Okay, so what's the value? Let's calculate. 9 exponent 9 multiplied by this 36 exponent negative 6 multiplied by 12 exponent negative 6 divide again by 32 exponent negative 2 square. Okay, so the answer is 37.9 969 Newton. So this one is to the left. Direction is to the left. Okay, good. So now we have the each forces. Now we can find resultant. We can find resultant. So what's the resultant force on Q1? What's the resultant force for Q1? Okay, so remember about the direction I mentioned before. Okay, I mentioned about direction before this one. Okay, I want to write it again here. Yeah, just want to put it over here. So for you to remember. Vector, the direction, we always use positive negative sign to represent. So like you can see, this one is to the right, this one is to the left. So to the right is a positive, force. So we can say this is a positive force, and this one is to the left. To the left is a negative force. So this is a negative force. So the positive and negative sign is to represent the direction. We ignore the negative sign for charge. Even though we ignore the negative sign for charge, however, for direction, we still need to put the positive negative sign to represent direction to the right or to the left. Direction to the right is positive force, direction to the left is negative force. Okay, that's the positive negative sign still used in direction, but it doesn't use in the to find the magnitude, doesn't use in the charge. Okay, but we still use a positive negative sign for direction. Okay, so now to find the resultant force on Q1, total up between F21 and F31, total them up. So we can see F21 is a positive force, so it is a positive F21. Okay, total with, however, F31 is to the left, so it's a negative force, so we should put a negative sign for direction, negative F31. Understand? So the positive negative sign to show the direction. Positive means to the right, negative means to the left. So when we put the direction like this, we can see that these two forces cancel each other. You see, cancel each other because the opposite sign. You see, that's why in minus, when the force is opposite direction, they cancel each other, they minus each other. Okay, automatically when we total them up. Okay, so now let's write down the value there and calculate. So this is 150 plus a negative. This one is because to the left, negative 37.969 Newton. So what is the final forces? So 150 minus 37.969. So I get positive 112.031 Newton. Okay, so what does it mean by positive value here? It means the direction. This positive means direction to the right. So the resultant force is to the right. Yeah, positive resultant force means the resultant force is to the right. So we can say the resultant force is to the right. Understand? That's a resultant force. Actually, it's not so long. It's after cancel, it becomes shorter. So that's a resultant force to the right. Understand? Resultant force to the right. So is that correct? My answer? Yes, the resultant force is 112.03 Newton to the right. To the right. That's correct. Yeah, I'm correct. That's my resultant force. After F21 and F31 total up, we get the resultant force to the right. Okay, we have remaining force to the right lah. Yeah, after cancel by forces to the left. Okay, so that's for question A. Now let's look at question B. Let's look at question B. Suppose the charge Q2 can be moved left or right along the line joining this charge 1 and charge Q1 and Q3. Okay, that means this Q2 can be moved left or right along this line. Determine the distance from Q3 where Q2 experiences a net electrostatic force of 0. Okay, this is the keyword. The net force of 0. Okay, so the word net, the word net is actually the same meaning as total. You know, this total actually is net force. It also means the resultant. Resultant force. Yeah. Net force means resultant force, or total force. It's the same meaning. Total force, net force, resultant force. So right now, for question B, he said net force, the resultant force is 0. The net force is on who? On Q2. This is the important part. Q2 experience resultant force 0. So where is the location? That means this one asks for location. The location distance from Q3. That means how far is it Q2 from Q3? How far is it? That means I want to find this distance. I mean the highlighted one. The highlighted one. I want to find this distance. Yeah, it's no longer 20 cm. Yeah, no longer 20 cm because this Q2 can be adjusted to the left or to the right. So it's no more 20 cm. Okay, so I want to find this distance. I can put this as distance x. I want to find this distance x, this location, where the resultant force on Q2, the Q2 experience a net force of 0. That means the resultant force. Okay, the resultant force on Q2 now is 0. The resultant force on Q2 now is 0. So what is x? What is x? Means distance from Q3. Q2 from Q3. What is x? When the net force on Q2 is 0. So how to do this? Okay, let me redraw this diagram because I don't want to mix up with question A. I redraw the diagram. Okay, let me redraw it. Yeah. Okay, I rearranged already. As you can see, okay, I rearranged just now I put it over here. Okay, now B. I start with B. Okay, so this is what it mentioned. Yeah, mentioned in the questions. So I want to find this x. Okay, I want to find this x. Only the Q2 can be adjusted. You see, only the Q2 can be moved left or right. He say only move the Q2. Only move the Q2. The Q1 and Q3 are fixed in place. So what I can say is the distance between Q1 and Q3 is still 32 cm. It's fixed. 12 plus 20 is 32 cm between Q1 and Q3. These are fixed. Yeah, I can say this is fixed. Only this one can be movable. Can be moved. This one can be moved. Yeah. The other two is fixed. So this one can be moved either left or right. Can move left or right. So what is the distance x when the forces, the net force on Q2 is 0? That means I want to find the net force on Q2 here is 0. So our focus is only on Q2. Understand? Basically, if the forces only on Q2, so you just need to draw the forces on Q2. Don't draw the force on other charge. Only draw the force on Q2. Only draw the force on Q2. Okay? Understand? So no need to bother. Like just now, the question A is forces on Q1. So you just draw the forces on Q1. But question B, he is talking about distance from Q3, not the force on Q3. Is distance from Q3, where Q2. So Q2 is our focus. Question A, the focus is on Q1. Forces on Q1. So I circle the Q1. For question B, the focus is on Q2. So I circle the Q2. Yeah. So we draw the forces on Q2. Just now question A, draw the forces on Q1. Question B, draw the forces on Q2. Yeah, because it said Q2 experienced a net force of 0. Q2 experienced a net force of 0. So I need to know what are the direction of forces acting on charge Q2 only. Okay, so let's look back to what are the forces acting between Q2 with the neighbor charge. Okay, so between Q1 and Q2, they are opposite charge, they attract each other. I can say they attract each other. Understand? This is F 1, this is F1 on 2. Okay, so 2 and 1, and also we need to know about 2 and 3. We need to know about 2 and 3 also. 2 and 3, what are the forces acting? 2 and 3. Okay, let me draw it out. Between 2 and 3, also opposite charge. Opposite charge, they attract each other. So we can say they attract each other. So here we have F3 on 2, and this one we have 2 on 3. So we have these two forces attract each other. But now our focus is on Q2, so you actually no need to draw the forces on Q1 or also forces on Q3. Just these two forces you draw only. Just these two only. We need to find the resultant force between these two forces, F12 and F32. When these two forces cancel each other, they become 0. And at what distance x, when this F12 and F32 cancel to become 0, we will need to find this distance x. That's our focus. Okay? Okay, so we can start off with, what can we start off? We can start off with resultant force on Q2 is 0. Okay, resultant force on Q2 is 0. So we know that important, we use the positive negative sign to denote the direction. Forces to the right is positive, forces to the left is negative. So we can see which forces is positive. F32 is positive. F32 is positive because to the right. F12 is negative. Negative force because to the left. Understand? Okay, now we can write it down over here. F32 is positive because it's to the right. F32 is positive because to the right. Total with the F12 is negative because to the left. We need to put a negative sign, direction to the left. This is negative F12 equal to 0. So when these two forces are total up, they will cancel each other. They cancel each other because they have opposite sign. Understand? They cancel, and then that's why you get 0 force at Q2. Okay? But we don't cancel them. Yeah, we don't cancel them. We want to find the value of x. Actually, our focus is to find the value of x distance from Q3. Okay? So now, okay, so look at here. Distance from Q2 to Q3 is x. If Q2 to Q3 is x, and between Q1 and Q3 is 32 cm, which is changed to SI unit 0.32 meter divided by 100. So the distance between 1 and 2 will be 0.32, the long one minus the short one, which is 0.32 minus x. We got this 0.32 minus x. So distance between 1 and 2 is 0.32 minus x. Understand? That's how. Don't put this as y. Don't put this as y. Put this as we want to have the common terms here, xx. Okay? Alright. Now, let's continue. Yeah? Let's continue. Okay, so we have so k q3 q2 over r 32 square, and then this one we have negative k q1 q2 over r12 square equal to 0. Okay, this negative because direction to the left. Okay, now continue. Okay, so this negative go, okay, this one can go to the other side. Okay, can go to the other side, become positive. So KQ3 Q2 over R32 square equal to KQ1 Q2 over R12 square. Okay, so now yeah, negative sign go to the other side, become positive. This K we can cancel. This K we can cancel because they are common. And then we can see here we have another common thing, which is Q2. They also can be cancelled. They also can be cancelled, this Q2. And then now let's substitute the value. Okay, let's substitute the value. Okay, so Q3 is 36 micro. Q3 is 36 micro. Okay, so 36 micro, let me see, 36 micro. Okay, micro, you need to change to SI unit. Micro is -6, -6 Coulomb, and then Q1 is 12 micro, -6 Coulomb. Okay, and then distance, we have R32. Distance between 3 and 2 is x. This one is x. Okay, this one is x. X 32 is x. Between 1 and 2 is 0.32 minus x. I put this as 0.32 minus x. Okay, square. And then now, so okay, let's continue. Actually, if you look at here, this one 12, this one 36, this one can be cancelled, cancel, and then this 12 and 36 here become 1, and this one become 3. Okay, and then you can rearrange. This is all mathematics onwards. Yeah, from here, this one go to the other side. Yeah, this one go exchange places. Okay, and then okay, let me solve it for you. Yeah, so this one become like that. Okay, okay, this one is 1 3. Okay, 1 3. Okay, 3 go below here. And then how do I solve this one? I'm going to solve this one. Just square root both sides. Square root both sides. Square root both sides. Square root. So actually, square root both sides. Actually, this one you have a positive negative sign. Yeah, positive negative sign. Okay, let me calculate what is the value there. 1 divided by 3. Okay, square root answer it is. So this one you will get positive. Sorry. Let me continue. This one become positive negative. When you square root something, you will have a positive negative sign. Don't forget. Okay. 0.5774. Okay. And then when you why I square root this one, because I want to remove the square. You understand? I remove the square, so it become something like this. Yeah, like that. You see that? So this one has two possibility. 0.32 minus x will and then you multiply, you get 0.5774x, or it can be 0.32 minus x and then negative 0.5774x. Okay. Okay, so this one I multiply above lah. Yeah, I just multiply this x to the top and I get this. Okay, and then let's continue. Okay, let's continue. This one 0.32, and then this one minus this one become 1.5774x, and then x equal to let's calculate 0.32 divided by 1.5774, and I get x is 0.203 meter. Yeah, or this one is 0.32. You get this one second one minus 0.5774. I get this one is 0.4 226 x. Okay, which is the answer you will get 0.32 divided by answer. The answer is 0.7572 meter. Okay, so which one is the correct answer? Which one is the correct answer? What I can say is hold on a second. Okay, you look at here. Which one is the correct answer? Is it 0.23, is it 203 or 0.75? Look at here. Look at here, because in terms of mathematics, when we square root both sides, we must add the positive negative sign. And because of that, I end up having two answers. But which one should be the correct one? We cannot accept both. Why? Look at here. Which one is the correct one? Look at here. X is the distance between Q2 to Q3. Yeah, to Q3. But the distance between Q1 and Q3 is only 0.32. 0.32 meter. See that? So the furthest Q2 can go from Q3 cannot be more than 0.32. Yeah, because Q2 must be in between Q1 and Q3. Must be in between Q1 and Q3. If Q2 go beyond, then that's not the correct answer. Understand? So the X must be less than 0.32. Yeah. So the X must be less than 0.32 meter. So that the Q2 is in between Q1 and Q3. Understand? It must be less than 0.32. So it seems that this is the correct one. This is the correct one. This is not, because X cannot be 0.75. 0.757 is already more than 0.32. Then if 0.75, then Q2 will be at the left hand side of Q1. Yeah, will be more than 0.32. So this is not possible. Yeah, this is not possible. It's already more than 0.32. So this is the correct one. Yeah, less than 0.32, because Q2 must be in between Q1 and Q3. Because he already show you here, in the diagram, Q2 is actually in between Q1 and Q3. So this is the correct answer, 0.203 meter. So is that correct? 0.203? 0.203? Yes, that's the correct answer. 0.203 meter. Okay, 0.203 meter. Okay. That's the correct answer. That's the correct answer. So, okay, that's all for these questions. I hope you understand, and anything you don't understand, just leave a comment below. Yeah. See you again. Bye.